I'm Samir Dhurde, and it's a pleasure and honor to welcome Professor Martin Hendry for a brief chat about outreach in the LIGO project and in general as well.
Thank you, Samir. Delighted to be here.
Welcome, Professor. We know that you're a practicing scientist. You're the chair of the School of Astronomy and Physics in the University of Glasgow.
Yeah.
And you're also the chair of the EPO group, the Education and Public Outreach group of LIGO.
Yes.
So we are so excited and interested in knowing how things are working in LIGO on the outreach front. But maybe if just to get on with the first basics of the interview, how is it that you got into outreach as a practicing scientist?
Sure, an excellent question. I suppose I've always had a fascination with astronomy, as so many children have. I'm sometimes asked, how do you get children interested in astronomy? And I feel the question should almost be the other way around. How can you stop them being interested in astronomy? They are always just so naturally curious about space and what's out there. But then what seems to happen, I suppose, is that our formal education system kind of beats that out of them because the way they study science at high school in some countries around the world is all about passing exams and not so much about just being curious and asking questions. So in my case, I was very fortunate that my ability at doing science was rather good. So it meant that I was able to easily do the exams without losing just that natural curiosity. And I was always asking my high school physics teacher questions that went beyond what we needed to know in the exam. Okay. And he was so patient with me. He was always great at answering those questions, even though he could easily have said, oh, you don't need to know that. Don't worry about that. Yeah, but he always tried to give me answers. And I think he also gave me a good sense that there were many things that we simply didn't have the answers to. And I was comfortable with that. And I think when I became a student myself, the professors I had at Glasgow University, because I did my first degree there and my PhD there as well, they had a similar approach. They were always willing to try to answer questions that went beyond what was really in the syllabus for the course. And then after my PhD, which was in cosmology, so I'll come back to that in a moment, I suppose that is part of the story as well. But in particular, I went to a postdoc at the University of Sussex in England, and the person I was working with there, although to be honest, he was great at just letting me go and work on my own projects. But if there's one single thing he inspired me on, it was outreach. And the person is John D. Barrow. So I think, he's a world-renowned cosmologist and mathematician, but also very renowned for being a passionate communicator about science, and also actually about science that some people might regard as difficult. So what I mean by that is that, yes, you can be involved in outreach in astronomy, and you can do it at the level of, wow, the sky is wonderful, it looks amazing. Yes, it does. But some people, I think, are searching for a deeper understanding of some of the questions that modern astronomy and modern cosmology has confronted. Things like, how did the universe begin? What is dark matter? What's dark energy? Why is the universe accelerating? So I was beginning my postdoc career actually before we'd even discovered that acceleration of the universe. But I was seeing a lot of these big questions unfold in a kind of curious way, which meant that as we tried to answer these questions, we realized that it was just giving us even more questions to answer. So the way I like to put that now to our own students is that I tell them that we now know less about the universe than we thought we did when I was a student myself. So to summarize, my answer to the question would be that I always had an interest in finding out more than just passing the exam. And I think that passionate interest in going deeper into these big questions was encouraged by my high school physics teacher, my undergraduate professors, and then during my time as a graduate student and postdoc, and people like John Barrow. So all of that meant that it was quite natural for me to get involved in some form of public engagement. And when I moved back to Glasgow as a professor, as a faculty member, we had at that time a very active program in astronomy for the Department of Adult and Continuing Education. So that was also helpful because it meant that my focus was not just on enthusing high school students, but also talking to adults, people that, had maybe left formal education decades before, but still retained a fascination with what astronomy tells us about our place in the universe. So all of this, it has placed me where I am. But all of that was really before I became directly involved in gravitational waves.
Okay.
So my PhD was in cosmology, but in the study of galaxy surveys, addressing problems to do with measuring distances to galaxies. And I became aware of the work that was happening in gravitational waves. This was quite early. It was the late 1980s, because in Glasgow, where I did my PhD, they had a group developing the instruments that would much later become LIGO and advanced LIGO. And it seemed to me that they were tackling really fascinating problems that were not yet mature in being able to gather data and have a realistic chance of observing gravitational wave sources. But that's clearly the journey they were on. And it meant that I wanted to be part of that when it finally happened. So I kind of formally got involved in gravitational wave science at the same time as I became involved in gravitational wave outreach. And I think that is an interesting part of the tale as well, because I already had maybe a decade's worth of experience of doing outreach about astronomy to the general public. Mm-hmm. But what my colleagues that were working in gravitational waves were really conscious of was, at this point in the late 2000s, they had this crucial stage in the development of the field where they needed to do outreach to other astronomers, or maybe even, to other physicists. So that also excited me, because it made me realize that although I'd been mainly up until that point doing outreach to the general public and to high school students or elementary school students, that actually I found it really quite interesting to engage other scientists in the possibilities of gravitational waves. And that allows you to approach it differently, because they know a lot of physics already, but maybe hadn't thought about the potential, the amazing potential of gravitational wave astrophysics. So a very long answer to your question, but I think it tells you that from the very beginning, the inspiration I received when I was being trained meant that it was always natural for me to think of communicating the science I was doing to other scientists and to the public. And it was partly also just being in the right place at the right time. That's what the gravitational wave collaboration really needed at that time, because they had to spread that message first to the rest of the astronomy community and then to the general public. And that's really where the EPO group within the LIGO collaboration was born in 2008. So we've just passed 10 years since we were first formed.
That's such a great story, actually, of your career progression and then getting into outreach. And you've been active at the right time when you've seen a great evolution in astrophysics itself.
Yes.
And then the science of detection of gravitational waves and this huge discovery which everybody's excited about. And now we are going to the next stage where the LIGO-India detector could add the crucial direction finding element as well in that. And so the country is excited. I think the students are excited. We are starting our own group here in India, which does a lot of outreach activities. And it would be great to get guidance at this time from experienced people as yourself.
Sure.
We would like to know a little bit about the evolution of the LIGO Education and Public Outreach Group.
Indeed. So as I was saying, my own involvement in the LIGO scientific collaboration formally began in 2008. That's when I joined the LSC, even though I had been talking with my colleagues in Glasgow that were involved mainly at that point in the instrumentation side for several years before that. And when we formed the EPO group in 2008, of course, one of the first questions we asked ourselves was, well, what should we be doing? And the world was a little different then. I guess it was quite early days for social media. And therefore, if I look at what we do now, that's perhaps the biggest contrast. We now have a much greater presence on the internet, and a lot more of our EPO effort is channeled into internet interaction, social media through Facebook and Twitter and Instagram, and we have our own YouTube channel. All of those activities have been built up. So I can say a little more about those and how we've approached that. But if I go back to 2008, our principal effort then was actually in face-to-face communication. And that was building on the existence of a visitor centre at the LIGO Livingston Observatory, which was a very valuable outreach tool in a region of the US where, frankly, interest in science is not terribly high compared with, for example, California or Massachusetts, where the two leading groups that run the LIGO laboratory are situated.
This would be because of the remoteness of the detectors.
Well, I want to be diplomatic here. The remoteness of the detectors, but I suppose also, frankly, other socio-economic issues that I don't want to get into. It's, I'm not a US citizen, so it's maybe not my place to comment. But let's just say that even fundamental discoveries about astronomy that I just took for granted in the UK that everyone knew about, things like, the Big Bang and so on, these were rather controversial in areas like Livingston. Right. So that meant that one of the ways in which the visitor centre was functioning was not just to tell people about gravitational waves, but to reach out more generally about the importance of science in our lives and the role that science can play in education and opening up career possibilities. So bottom line was, we thought that was a good place to start from. And in fact, as is so often the case with science, your ideas are kind of influenced by and shaped by the funding opportunities. So it turned out that there was an NSF, a National Science Foundation program, that could target some states which were identified as having lower socio-economic status. And you could target funding for outreach programs that would seek to promote science and STEM in those states. So the group of us that got together were led by the chair of the EPO group at that time, Marco Cavaglia, who was at a university in Mississippi at that time. So Marco became the principal investigator of a large-scale project that we got funded by the NSF to build a travelling exhibition on gravitational wave astronomy. So we called it Astronomy's New Messengers, and it sought to enthuse the public with the possibilities of gravitational wave detection, but also to highlight that this requires very advanced technology, and it also draws upon a wide range of scientific and technical skills. And, hey, you could pursue a career in all of these different fields. So that really did occupy us a lot for the first few years. The exhibit was ready in 2009, which was quite appropriate because that was International Year of Astronomy. So we premiered at the World Science Festival in New York, but actually most of the time it spent its time travelling around the southern states of the US, where this NSF program was targeting outreach. Now, in parallel, we were doing similar things in Europe, in the UK in particular. And I did enjoy doing that. I enjoyed the fact that there was a great challenge in talking to people at a science festival or a museum. You never quite knew what they were going to ask next. It was more spontaneous and more informal than just giving a public lecture. But we did a lot of public lectures as well. So it was a kind of mixture. But as I said, mainly focused on face-to-face outreach. But then gradually, we built up our social media presence, our internet presence. Firstly, just improving the LIGO.org website to make it more friendly for public viewers. And one specific initiative, which Marco and I kind of pioneered together, was the creation of what we call our science summaries. We still produce them now. In fact, the crucial difference is that now people actually read them because LIGO is so high profile. But back in 2011 or so, when we first proposed this, I guess they weren't all that widely read, but I think they're a very good idea in principle. It's essentially a distillation of the results of our scientific papers, but without all of the equations and the formal language taken out, presented at the level that someone who's maybe a high school student or a teacher can easily access and can get the essence of what our science is all about. So I really enjoyed working on those. And I think to look at this in the context of just general advice about how to do outreach, I think it kind of highlighted that our approach to outreach was based on this being a shared responsibility of everyone in the collaboration. Well, not literally, but in principle, anyone in the collaboration could get involved in EPO. So what we weren't trying to do was to say, well, we'll do the science and let's employ someone else to do the EPO.
Okay.
Instead, it was very much an integrated responsibility. Okay. And these science summaries were a great example of that, because the summaries were written by the people that actually wrote the papers, the paper writing team. And the EPO group's job was just to assist with that and to make sure the writing wasn't too technical. And also, of course, to try to publicize these science summaries. So that's probably, I'm talking a lot here and we should move on to other topics perhaps. But in summary then, over the course of the last 10 years, we've gradually shifted from face-to-face communication, where the kind of flagship activity was things like science festivals with our exhibition. We're still doing that, but we've now expanded and diversified into lots more online presence. Right. And a good flagship activity there is our science summaries. Again, we're really quite proud of those. Yeah.
Lovely. Yeah, that's a very that's a very great tip that the practicing scientists should actually be involved in outreach. And we have such great examples like yourself and many other leaders in the LIGO community who are doing the outreach themselves, and they take out time to go to the people face to face, and also they're communicating on the internet to a lot of other people who otherwise they would not have reached. I think there's a good balance between that.
I think so. And I think to help make that happen, one of the things that we've done within LIGO, and I would advise any scientific collaboration to think about doing this too, is we try to create good resources and to make them easily available to the practicing scientists within the collaboration, so that if they do want to get involved in outreach, it's easy for them. They don't have to perhaps write a talk from scratch. They can go to our wiki and find their good animations, good images, good descriptions that they can easily then incorporate into their presentations.
Lovely. That's a great help to the scientists who are willing to do that. So now that we see that, you have been there at a phase when you had to actually explain the presence of LIGO, and then you had to explain this big technology which is being developed. It's expensive as well. And it was kind of, a responsibility that you explain your funding. People who give you funding through their taxpayers. So it was a kind of a responsibility that you explain this to your taxpayers.
Yes.
But now that this great discovery has happened, and we are actually at, and now that we are being actually recognized as a new window on the universe, how do you see outreach changing in this phase?
That's an excellent question. I think that there's not maybe a single answer to that. That I think outreach can take many forms, but let's look at a few examples of aspects of how it might change that we're already thinking about. So firstly, there's the political outreach. So you rightly identified that was something we had to address before. And indeed, just after the first detection, the LIGO leadership in the US were invited to give a presentation to Congress, to senior politicians in the US. And actually, they expected that a lot of the questions would be about the spin-off technologies and the kind of applications and applied technology that comes from LIGO. To be honest, mainly they just talked about how amazing black holes are, So I think even the politicians at that moment got that this was just one of those gee whiz, amazing discoveries. You just revel in how spectacular this was. But at the same time, we've been aware that we need to keep thinking about how to justify the investment in LIGO. Sure, in terms of the inspirational science, but also in terms of the spin-off technologies. So we now actually have a subgroup within EPO which is on political outreach. And it's mainly US focused, but I think that some of the general approaches that we've adopted could be easily translated to other countries. And just, to a little like we do with public talks, the principle is to gather information so that it's easy for scientists within the collaboration, if they need to quote some statistics at their local politician, then, make it easy for them to do it. Create some flyers so that they can give them to the politicians. So that's one aspect. Let me just highlight two others. So one is formal education. And there, again, the world has changed because gravitational waves are now widely recognized. So what that creates is an opportunity to embed ideas about Einstein's theory and gravitational waves and what it might tell us about the universe within the formal education system in as many countries as we can. So I'm from Scotland, and again, I had a wonderful opportunity to be part of the design team for the high school physics curriculum that students take just before they leave to go to college or university. So now there is special and general relativity and some cosmology and some particle physics within that syllabus. And I think there's added value because the students don't just learn about it, but they learn that it's being done by scientists from their own community. Right. So that's something that, again, within the global EPO group, we're trying to promote so that other countries, if there are opportunities to get more LIGO science into the high school curriculum, the college curriculum, let's help to make that easy for those countries to create resources that teachers and professors can easily use. And then the third dimension is informal education. So in a way, that's a bit like what we did before with science festivals and museums. But I think what we're trying to do is, because gravitational wave astronomy is now much better known, is to shift it from being a kind of a passive exercise to being much more of a participative and active exercise. So what I mean by that is, yes, we could always guarantee that talking about black holes and showing these amazing animations and images would capture the attention of audiences at science festivals or at big public talks. But now what we want to do is to try to get people more directly involved in analysing the data. Right. So there's been a big push towards the Gravitational Wave Open Science Centre. So that overlaps a little bit with the formal education because it involves knowing about Python and so on. But we've tried to present those materials in a form that actually just anyone, even if you don't have a high school physics education, you can still have a go at downloading the data and playing with it. And then there's other similar citizen science activities that people can undertake. For example, Gravity Spy, that involves analysing output from the detectors and helping with classifying glitches from the detectors. And as we approach the next observing run and then looking even further ahead to the era of LIGO-India, let's return to something you mentioned, which is that LIGO-India will enhance further our ability to localise on the sky the position of gravitational wave sources. So building on the fantastic outreach that we had around the binary neutron star discovery, what I really want to do is to get to a point where members of the public, if they have a telescope, that they feel enthusiastic to actually go out and look for themselves. Okay, maybe the chances of them finding the electromagnetic counterpart of a gravitational wave source are really small. But, people buy lottery tickets every week and the chances of them winning are really, really small. They still do it. They dream about that possibility. Right. I would like, the vast number of enthusiasts for astronomy to feel that they can actually participate in all of this, that they can go out, look through their telescope and they can dream that they might discover a kilonova. So that's a big shift in how we do outreach, because when we made the first detections, the announcement was super secret for months before it was formally announced. But we are changing. We're changing to a new regime where the alerts will be public, more or less immediately. So again, our EPO efforts, I think, also need to change too, to make the public feel as if they have more direct involvement in the whole LIGO adventure.
Lovely to see these success stories and particularly these special citizen science project which
Yes.
people can participate in.
Yeah.
That's great. So I think this is something which all projects, the big projects which are coming up in the world, which are related to astronomy and other sciences, could take up, where citizens could be involved in being part of the discovery.
Yeah.
Or even just to know the method of how the projects work. That's lovely. Do you have any particular suggestions for the nascent LIGO-India group, which is just getting into outreach?
Sure.
What
Yes,
path
I've been
could we
thinking a lot
follow?
about that. And I think, again, there's a mixture of advice and suggestions that are almost universal. They should apply anywhere in the
Right.
world, but also some lessons that we've learned, which is know your audience and be willing to adapt to the local community. So with regards to the latter, aside from that rather obvious common sense general advice, I would be the first to admit that I don't know your local community as well as you yourselves do. But I think I'd like to learn more, and at least to draw upon the experiences we've had in some other countries to see how we could help you adapt resources that we've generated globally to be more tailored to the local environment. So let me give you a couple of specific examples. As I said some minutes ago, one of the things that we targeted initially with the EPO group, because there was this funding opportunity to build the exhibit, was the states and generally the southern part of the US that have been identified as socio-economically underperforming when it comes to STEM. I imagine there are some areas in India where that's also the case, where there's a recognised need to build up the engagement with STEM in school and then encourage people about the possibilities to go on and study in college. So I think that's definitely an area where we can share our experiences from the US and from other countries. Indeed, we're still doing that. We've got some outreach programs involving members of the collaboration who have Native American heritage.
Okay. And
they're going into areas of the US where there are strong and very proud Native American communities, but where there is no tradition of people going to college to study STEM subjects. So again, that's an ongoing activity in the US, and maybe that's one where we can share experiences with India. And I suppose the other one to mention, which is quite different, but I think again, one where there must be enormous potential here in India. At the same time as, yes, there must be large parts of the country where there are concerns about STEM engagement. What I've been impressed by in my limited experience of India is just the huge enthusiasm that your young people have for engaging with the internet and engaging with modern technology in the form of smartphones and computers. So for example, things like our citizen science programs, if they could be maybe adapted, maybe translated,
right,
so that they were more easily accessible to that vast population of young people you have in India who are, even if other aspects of their communities are limited in what they have, the kind of metrics that we would have in the West in terms of material possessions, it might be that those are not so high, but nonetheless, the awareness of, the engagement in modern IT technology is very high indeed. And that seems to me a great opportunity that we could multiply by 10 the number of people using Gravity Spy, for example, if we just engaged more within India. So we'd be very keen to work with you on that, on ways in which we can learn from our experiences in other countries and perhaps adapt to the Indian situation.
So you'd like to know a little bit more about these citizen science projects that are around in the LIGO group,
Yes.
which has been specially formed so that everybody can participate in the discovery process. Also get the fun in the scientific method. So maybe can you give us a few examples?
Sure. Yes. So let me say first a little bit more about Gravity Spy, because after all, we've mentioned that already, and then I'll look at some other ones too. So Gravity Spy involves real human beings using the computers that reside within their heads to help us in the classification of the patterns that emerge from the detectors. So a lot of those patterns are produced by what we call glitches. These are a real nuisance when you're trying to detect gravitational waves, because they can swamp completely the signal that you're trying to detect. So they take a variety of forms. You can make pictures of them where you show the frequency behavior as a function of time. So we call these time frequency graphs. And essentially the way that Gravity Spy works is just to let people look at lots of these, and then they use that as a way to effectively train their brains to be good at recognizing the different types of glitches. The human brain is amazing at pattern recognition. So that's the goal with Gravity Spy. So that, I think, is something that could be easily adapted. It does require access to the internet, but it doesn't require a great deal of bandwidth. These are not terribly large files that you need to download. So it could be something that really on a large scale, people across India could get involved in. And then another example of a citizen science project is actually on the electromagnetic follow-up side. As I said, this is a new development as we move from the alerts being secret, really, until we're sure that we've actually got a detection, to a completely new world in which the alerts will be made public more or less right away. And I understand that there's a network of robotic optical telescopes that's being created in India. And indeed, there are many other robotic optical telescopes in other countries around the world, which can be accessed, again, if you have a good internet connection. So that could be an example of something you could get maybe high school or even elementary school children involved in. All you maybe need is an enthusiastic school teacher, just like I had. That's what started me off, who's willing to support their students as they perhaps, when a LIGO alert comes along, that information that will be made available will include a position on the sky. And that means that, well, the sky position, which of course, as we said, will become better once LIGO-India begins operation, that sky position still might include dozens of galaxies. And essentially, astronomers around the world will need to organize themselves to look in all of those galaxies for the electromagnetic counterpart of a gravitational wave source. It could be that really could be something that the public could get involved in. Not everyone has a telescope in their backyard,
of course.
But a lot of people in this country, a lot of people in my country might be interested in making use of some of these robotic telescopes. So working through the network of professional astronomers, but we can link them together with high school children.
That'll be a great opportunity for children to reach telescopes, which otherwise
they would not. Exactly. Yeah.
I also know of some games which people love to play.
Yes, I should have mentioned that too. So there's several that have been developed. So one is a really fun one called Black Hole Pong, which is like a classic game. I'm old enough to remember when this first came out, and computer games were very primitive in the 1980s, but Pong was one of my favorites then. And this is where there's essentially like a ball, a little pixel on the screen that's moving around, but you can deflect it, you can change its position using the gravity field around a black hole. So that's great fun. So our colleagues in the University of Birmingham in the UK developed that game. They've developed several others. So there are other games which are just fun interactive games, essentially using some aspect of gravitational wave science to mimic a kind of an interactive game that maybe people might be familiar with already. But there's another one which is a little different, and it's to do with running your own gravitational wave detector. It's called Space-Time Quest. And it involves thinking about how to design that gravitational wave detector. You've got a certain budget available. And essentially what the game lets you do is to use that budget to decide how much money you put into the mirrors and the lasers and the vacuum system and everything else. And then at the end, the output from the game is how sensitive your detector is. So we found with high school children, this is a very good way to teach some important general principles about experimental science, but you're doing it within the context of a fun game.
Yes.
So that's called Space Time Quest.
Okay.
And it's I can highly recommend it.
Lovely. We'd recommend that to our students to play. So you have worked all your life towards generating awareness about astronomy, increasing the understanding, and maybe also gaining support of the people. How have you managed your personal time as a practicing scientist, an outreach person, as a human being? How have you managed?
Well, I suppose, to be honest, I'm just one of those people that doesn't need to sleep very much. So that does help. Yes, there are times it's been challenging. I think being involved in outreach, some of it is just organising it and overseeing it. And that isn't so different really from aspects of my professional science role or my job as chair of physics and astronomy at the university. So, that involves chairing telecons and organising meetings and so on. But the part that I really enjoy and the part that kind of refreshes me and rejuvenates me is actually delivering outreach. So that can be at a science festival, it can be going into a classroom, it can be talking to the public in a lecture. And I think in 2016 alone, between February when we announced the first detection and December, I did more than 70 public lectures around the world.
All right.
So, that involves a lot of traveling, quite tiring, but every time you're presented with a different audience and they ask slightly different questions, it never gets old. It never gets stale.
Right.
You don't feel as if, not black holes again. So that's one of the things that's really helped me to maintain that balance. Of course, it's tiring, but I think it's helped me to maintain a healthy perspective on how this amazing discovery, which has inspired all of us, every time you talk to a new audience, you're kind of doing that all over again. You're inspiring them. Yeah. So I think the main lesson I take away from all this is that if you're a practicing scientist and you want to get involved in outreach, yes, of course, you have to be careful to balance your time, but approach it as something that will actually help the other aspects of your job, because it gives you a fresh perspective on how people meeting these ideas for the first time will interact with them. And, it means that sometimes I go back to scientific problems I've been working on and you get some kind of fresh inspiration because you've taken a step back from it for a little while.
I think that will go a long way in inspiring the younger scientists these days to take up outreach as a very important part of their work, and also to inspire the future generation to come and join the projects where I think the golden age of astronomy is on right now, and then we need a lot of students to come in as well. Yeah. So the part of understanding also public, part of support and generation of manpower, I think is one of the motives of outreach. I suppose
if I could make one very brief point to amplify that, I think seeking a career as a practicing scientist is a challenge. So even if you're not involved in outreach, it's going to involve challenges to your work-life balance. Mm-hmm. There's a lot of pressure for people to publish and to bring in research grants. So I think the one thing I would say is that for young scientists considering a career and how they will manage that career, well, at the very least, engaging with the public actually helps you when it comes to how you would give a talk to a grants panel. Okay. Because often, very often, when you're talking to a grant awarding panel, most of the people on that panel are not experts in what you're asking for the funding for. So the more practice you get at communicating clearly and succinctly your ideas about science to non-experts, well, maybe it makes you better at winning those grants as well.
That's a big added advantage of doing it outreach. Yeah. Well, thank you very much for being here.
Thank you. It's been a great pleasure.
Spending so much time with us. Thank you.
Thank you.